Okay, right. The 33rd question in kinetic theory of gases is the temperature of a gas is given. To what temperature the gas should be heated so that the RMS speed is increased by 3 times. Okay. So first of all, what is the relation between temperature and the RMS speed of a gas molecule? Okay, which is obtained from the kinetic theory of gases. Then based on that relation, we should do the we can calculate this solution. Okay, right. So what is that? From KTG, kinetic theory of gases. What is that? Pressure exerted by the gas molecules on the walls of the vessel, what is that? P is equal to 1/3 mn v bar square. Here n is the number of atoms presence in given mass, so which is equal to what? Number of molecules per volume. Okay, now this n is replaced in this equation. That implies P is equal to 1/3 m into n by v into v bar square. This v is brought into this side. That implies PV is equal to 1/3 m into n into v bar square. Why I couldn't write mass? Small m is the mass of each gas molecule. Okay, in the given mass, in the given gas, n number of molecules are there. So total mass is m into n. It is replaced by m. Therefore, this equation is written as 1/3 PV is equal to 1/3 capital M into V bar square. This is equation 1. Okay, and from ideal gas equation, PV is equal to what? N into R into T. Okay, here N, number of moles presence in terms of molecular weight, mass in grams by molecular weight m naught. That implies this equation is rearranged like this. PV is equal to what? M by m naught into R into T. This is equation 2. Now from equation 1 and 2, you should equate PV. So from equation 1, what is that? 1/3 m into V bar square is equal to m. From equation 2, PV is equal to m by m naught into R into T. On both sides, mm is cancelled. That implies V bar square by 3 is equal to RT by m naught, isn't it? So from this, you have to write V bar square is equal to, therefore V bar square is equal to 3 brought into this side, 3 RT by m naught. That implies V bar is equal to under root 3 RT by m naught. So from this equation, we get the relation between RMS speed and absolute temperature. Therefore, RMS speed is directly proportional to absolute temperature. Okay, that implies V1 bar by V2 bar is equal to under root T1 by T2. Now, given. Okay, what is given in the question? Initial temperature is what? T1 is equal to minus 50 degrees Celsius. You know, here we obtain relation between RMS speed and absolute temperature. So this temperature must be converted into Kelvin. That implies minus 50 plus 273. That implies what? 223 Kelvin. Okay. At this temperature, RMS speed V1 bar is equal to, say, called V1. Now, this temperature is increased from T1 to T2. You should calculate that value. Then what happened? RMS speed V2 bar is equal to 3 times of initial one. That means 3 times of initial is V1. Therefore, to obtain T2, use this relation. What is that? V1 bar is equal to what? V1. V2 bar is equal to what? 3V1. Isn't it? Equal to what? Under root T1. 223 by T2. This is required value. This V1 is cancelled. Isn't it? That implies remaining 1 by 3 is equal to under root 223 by T2. That implies squaring on both sides. That implies 1 by 9 is equal to 223 by T2. That implies T2 is equal to 223 into 9. Okay. When you simplify this equation, that means when you multiply this, you get the 3568 Kelvin. 3568 Kelvin. But there is no option in the question. So it may be converted in degrees Celsius. In degrees Celsius, T2 is equal to 3568 minus 273. It is exactly equal to 3295 degrees Celsius. So in the given option, A is the correct one. Thank you.